Hi, everyone. We'll be getting started shortly. All right. Good afternoon, everyone. Welcome to the August 2024 edition of Green Infrastructure, Climate, and Cities, a monthly seminar series that we've been hosting for about 10 years now, focusing on climate change's impact on cities in the Northeast and what we can do about it. So my name is Franco Montalto. I'm a professor here at Drexel and one of the co-investigators of CC Run. If you're joining us for the first time, you can go back to our YouTube page and the CC Run website and look at any of the older presentations. All of our seminars have been livecast, recorded, and archived. And as some of you know, we offer continuing educational credits for professional engineers who register. So if we could, please forward to the next slide. So today we're going to focus on urban heat mapping and talk about research that's been done recently in Philadelphia and Wilmington. And of course, this is a timely presentation given the extensive heat that we've experienced this past summer, really throughout the country. And so to kind of give us a little bit of level setting and kick us off, we have Dan Bader, who's the program manager for CC Run, and also a climate scientist from the Lamont Doherty Earth Observatory from Columbia University. And he has extensive experience preparing and communicating climate science and climate risk information to policymakers, specifically in states around the region. And once Dan gives this introduction to sort of what we've been seeing, we'll move on to Richard Johnson, who is the Urban Climate Resilience Manager for the Pennsylvania and Delaware chapter of the Nature Conservancy. And at the Nature Conservancy, he advances nature-based solutions to climate change in cities. So he contributes to analysis, development, implementation of conservation strategies that benefit both people and nature in the context of a changing climate. Previously, he was the director of community science at Drexel's own Academy of Natural Sciences, where he led this federally funded Philadelphia urban heat mapping campaign. And he will tell us more about the analysis that was done there. And then we'll move on to our last presentation. Certainly not least, Dana Veron is a professor of atmospheric science and climatology at the University of Delaware. She holds a joint faculty position between the Department of Geography and Spatial Sciences and the School of Marine Science and Policy. Dr. Veron also serves as a co-director of the Gerard J. Mangione Climate Change Science and Policy Hub at the University of Delaware. Much of her research is focused on detailed characterization of coastal winds, including sea breezes, with applications to pollution transport, weather forecasting, disaster response, and offshore wind resource characterization. So thanks to all of our speakers for joining today. Before we begin, I'd like to just remind you to please use the Q&A box, not the chat box, to submit questions. And I guess the format is we'll have each presentation, we'll have after the presentation a few minutes for Q&A. And then at the end, we'll open up the discussion to all of our attendees. And so with that, I'd like to hand it off to Dan Bader. to give us a little context on what we've been experiencing in terms of urban heat the last few months. Thanks, Dan.
Thanks, Franco. Just logistics. Do you want me to share my slides here, or is it
Yeah,
part?
please do if
Okay,
you have it. Yeah.
let me grab them. Sure. So just again, I'm Dan Bader from Columbia University, the program manager from CC Run, and as luck would have it, we're here first cool day in a while, discussing uh, extreme heat. And as we get started here, we'll look at a couple statistics of the heat over this past summer, but it's actually the first day since the middle of June, June 11th, where the high temperature in Philadelphia is not going to break 80 degrees. It's going to be in the 80s. June 11th was the last time, and the high today will be about 78. It's cooled out throughout during the day, but it's been a fairly warm summer. So placing it into context, June and July temperatures. Mean temperatures, the average temperature each day is about 3 degrees above average. When we break it down between maximum and minimum, we'll talk a little bit about this on the next slide. Minimum temperatures are one of the metrics we use to kind of understand the impact of extreme heats, and if it's not cooling off as much as it used to in the nighttime, it presents significant challenges to human health. Minimum temperatures have been running about 3.5 degrees above normal, so slightly more than the minimum temperatures for the past 2 months or so. So on average, it's been a little bit above normal this summer. I don't know the ranking. We still have a month to go here in August, and the next couple of days look a little bit on the cooler sides of where we'll end up. But again, thus far, a pretty warm summer that we've been experiencing. If we look at the number of hot days, starting with the days with the maximum temperature at or above 90 degrees Fahrenheit, we've had 30 days thus far this season or this year with those meeting that threshold or exceeding that threshold. Normal for a given year is 30 days, so we're right at the normal there with a few weeks left to go, so we might finish slightly above normal there. And days with maximum temperature at or above 95, this is quite interesting. Last time I was in Philadelphia, early July, they had just crossed over to 8 days. The normal is 7, and that was the early part of July. We're now up to 13 days at or above 95 degrees. So those days above 90, they've been quite warm. Warmest temperature on record at the airport over the course of the summer is 98 degrees. It's reached that on a few days over the course of the summer. Looking at heat waves, the number of heat waves on average, there are about 4 heat waves. We define a heat wave as 3 or more consecutive days with maximum temperatures at or above 90 degrees. Thus far this season, we've had 4 of those heat waves, one in June and then later part of July, and we just had one that ended spanning the end of July into August. Average duration of heat waves, how long these heat waves are lasting, average is about 5 days. There was one of 6 days, one of 4, and the other 2 were 5. Normal is five days in duration. So right at normal when we look at these heat metrics. Again, we have a few weeks to go. We'll see how the season wraps up as a whole. Placing it into context in terms of what's happening in general in Philadelphia, looking at trend analysis from 1941 to 2022, temperatures and precipitation, not the focus here, but included here on this slide as well, are both increasing. As I mentioned, minimum temperatures are increasing faster than maximum temperatures. That's been most notable over the past 50 years. And when we look at precipitation, the variability is greater over the more recent time period, the last 40 years or so, compared to the 40-year period prior to that. Why does that matter? It's becoming less and less predictable when we're forecasting seasonal or annual rainfall to take a previous sequence of events. So if we knew that 2 years of dry conditions were followed by 2 years of wet conditions, now we're seeing, let's say, 4 dry years in a row, or 3 dry and then 1 wet. It's not as predictable as it used to be. With precipitation, the increase in extreme events is probably the most concerning thing we've observed here in Philadelphia and in the broader Northeast as well. Jumping ahead, I just wanted to run through the climate projections that CCRN has developed for the city of Philadelphia and the surrounding region. This is probably good for a 100-mile land radius outside of the center of the city. And we don't focus, again, on these specific numbers. We're not telling you that it's going to be 6.9 degrees higher in the 2060s but this is a range of possible outcomes. Our projections are based on a set of global climate models and mission scenarios. We're presenting the results across the range of outcomes. Just glancing at it, by the middle of the century, temperatures may be 4 to 6 degrees higher when we look at the middle range of outcomes, and then by the 2080s, towards the end of the century, 5.5 to 9.5 degrees warmer. So we are projected to see a significant amount of warming as we continue through the century. Now, when we talk about changes in mean temperature, sometimes the smaller values don't really seem that significant. So if we have just a change of 2 to 3 degrees, let's say, it really doesn't seem like it's that much. However, if you think of the distribution of events and observe daily high temperatures, a 2-degree change is going to push every day that's over 89 degrees to 91 degrees. So if you're a facilities manager and your employees can't go out to work when it is above 90 degrees, that 2-degree change, which didn't seem very significant in the grand scheme of things, has now maybe doubled the number of extreme events and then doubled the number of days you can't send your workers outside. So when we look at projections of extreme events, days over 90, days over 95, those are expected to increase quite significantly as we head out into the middle and the end of the century. You can see close to double if the number of days we experience now may be common in the 2050s, and even more than that as we get out to the 2080s. In addition to hot days, number of hot days increasing, we'd also expect to see the number of heat waves to increase and also their length as well. So as we head into the next couple decades, again, warming is projected to continue. The rate of warming is really dependent on kind of the policy decisions that we're making now. But even if we are most aggressive with our emissions cuts, we'll still see somewhere in the order of 2 degrees warming by the middle of the century. So now is the time to start preparing for potential impacts. And with that, I think I will stop there and introduce and kind of feed it over to the next presentations, which are going to focus on the adaptation resilience side.
Yeah, so Dan, before we do that, just there's a question from Lewis in the chat, which actually was something I was going to ask as well. So that when, just reflecting on this particular summer, most of what you showed, I mean, with the caveat that we still have a few more weeks of summer to go, but most of what you showed said, it's on the higher side, but it's within the range of, at least this is my interpretation of what you said. It's sort of in the higher side of historical summers, but nothing particularly noteworthy. And, it's not extreme, but I think maybe this is just me, but the impression that a lot of people have is that this has been a brutal summer. And I'm wondering, does that have something to do with humidity? Or does it have to do with the fact that we just haven't seen a summer on the higher side for a few years, and we're sort of not used to these types of things anymore? Or am I completely wrong?
Well, I think that it's still been pretty warm. I think you're hitting at 2 points. One with the humidity, which I'll come back to, and the second is interpretation. I actually argue that these type of summers are fairly common now in terms of we're seeing the warming over the past couple of years. We've seen a bunch of hot summers kind of grouped together. So people may be just kind of changing their perceptions of the heat, but it is in part related to the humidity. A warmer environment, we can hold more moisture in the atmosphere. The combined impacts of heat, temperature, and humidity kind of really, that heat index is really what impacts us the most. There's kind of a measure. We have seen long periods of heat advisories and extreme heat warnings even issued by the Weather Service over the summer. I'm not sure how that compares to years past. Unfortunately, when you look at the data, keeping track of like wet bulb or dew point or even relative humidity is kind of sparse. So it's harder for us as climate scientists to kind of evaluate how those metrics have changed over time. But certainly the conditions this summer have featured high humidity in addition to the heat, which is probably why some folks are perceiving it to be more significant than, even though where it ranks, where it winds up in the ranking may not be, let's say, in the hottest 10. And I'm not sure about that, honestly, but the humidity does contribute to it.
But statistics on the humidity are not readily available. In other words, like whether we've had consecutive days of high humidity, greater clusters of consecutive days with high humidity accompanied by high heat, that type of information just isn't readily available.
It just requires a little bit more searching, let's say. Certainly something that we could put together, but it's not as abundant, let's say, as just Tmax or Tmin data, let's say.
Right. And it seems like my question has provoked a number of questions because all of a sudden the Q&A opened up. There's one question, what are the baseline years and the baseline period of comparison for the temperature projections? I think that was on one of your slides. It might
the base period for our projections, for our projections is 1981 to 2010. For the observations on the first slide, it's 1991 to 2020. The Weather Service updates every 10 years where their climate normal periods are. When we did the projections, it hadn't yet been updated. That's why we used 81 to 2010. There's also when the climate models end their historical runs and their future runs, which is also why we did 81 to 2010. The statistics I did on the first slide are 1991 to 2020, because I pulled that data right for the Weather Service this morning.
Okay. And there's another question here. And you showed, I think, on your first slide, some statistics about the minimum temperature. But the question here is from MJ is, did you analyze specifically changes in ranges and changes in ranges in nighttime temperatures? Does the minimum temperature typically correspond to the nighttime temperature?
In general, in the summertime, the minimum temperature does occur overnight. So when we looked at the trend in minimum temperature, it's what's happening overnight. Occasionally, you'll get some, depending on if there's a cold front passing, like if a cold front passes late in the day, you get some odd statistics of max or min, but in general, the minimum's the coolest time of the day, the early morning hours. Okay. And that's what would be included in the trend analysis that was shown.
And so the trends, I see, that was what you just showed. Okay. So Liz is asking a couple of questions. Just to follow up on the previous question is why you didn't use an earlier date for the baseline. She's saying that there was extreme heat in Philadelphia starting in the early 90s was her perception. So is there a reason why you didn't go back much further? Is it just availability of data?
Yeah, so when we look at the base period in our observations, we look at 30 years to average to kind of see the true climate metric and not the year-to-year variability. With the observations, we just use that most recent period is what's being accepted across this scientific community. For the climate modeling, what we're doing in the methods for our projections are comparing the 30 years in the future to the 30 years in the base period. So that's kind of the methodology there. If you looked, I think the difference between the statistics in terms of 81 to 2010 versus 91 to 2020 in the days of over 90, it went from 27 days to 30 days was the change. So it went up a little bit, but it's still a little bit of noise there. That's just the practice in the scientific community.
Okay. And again, a sort of methodological question. Heat wave you defined as 4 days. I guess Liz's comment here was that it might have been 3 days in the past. Has that changed?
We define it as 3 days in a row with temperatures at or above 90. That's the correct definition. The number of heat waves that we've had this summer is 4 heat waves. Sorry, okay. I apologize if I wasn't clear about that.
Yeah, great. And then another question, sort of the perception is that air quality has been very bad during these heat waves. I know there are sort of purple air sensors and different things, but do you have the ability now? I mean, we don't want to put you on the spot, but anything to say about whether air quality have had any trends of getting worse?
You'd have to look, I'd have to look at the data. There is data on this from EPA that you can look at, kind of the either the number of air quality advisories or the number of like times per year the air quality crosses a certain threshold, but I don't have any specific knowledge of if it's deteriorated. Certainly, certainly with the hotter conditions and more stagnant air masses, there's a potential for worsening air quality.
Right, right. Okay. And then lastly, Lewis has some questions about, or just a comment, essentially, that that there was a temperature drop in New York City the other day from 90 to 80, but the humidity was still so high that it still felt uncomfortable, which I guess is sort of consistent with what you were saying earlier.
Yeah, the dew points the past couple of days were in the 70s. So when you get dew points into the 70s, um, when you get dew points into the 70s, it's extremely moist air mass, and it's going to make lower temperatures feel much more unbearable.
Right.
And that's very atypical to get dew point values that high here in the Northeast.
Very atypical, you said.
Yeah.
Oh, so that's interesting. So, I mean, it suggests that it might be interesting to look at trends in dew point, if such a thing is possible. All right. I know we said no more questions, but there's one more that just came in. Do you have an impression as to whether the modeled interannual variability in metrics like days above 90 degrees Fahrenheit is similar to what is observed?
I believe because of in part, this is going to be because of the methodology that we use in predicting extreme heat and extreme daily events is a quantile mapping. So it is in part trained on the historical information, but I'm not sure off the top of my head what impact that has in terms of the variability. In our previous results or previous methods, when we're using the delta method, which would preserve the variability from the historical period, then it would be unchanged. But here the methodology is slightly different, and therefore I'd have to look at it.
Okay. All right. Well, thanks for that overview, Dan. I think it really helps just, to sort of connect what we've been perceiving outside and experiencing this summer with some of the research that we're about to talk about now in terms of adaptation and measurements. So with that, I'll hand it over to Richard. And Richard, if you'd like to share your screen, please go ahead.
All right, thanks, Franco. And yeah, hopefully my slide deck is going to be loading here in a second. And yeah, Dan, that was great. I mean, look at a statistic like 67 days of days over 90 in the 2030s, and I don't want any part of that. So, second, my slide deck. Can you all see my
No,
slides?
it says you've started screen sharing.
Okay.
You have to double.
Sorry about that. Yeah, maybe. What's that? Because I like to see like the chat and stuff. I have a particular way that I usually share my screen. It doesn't seem to like that. So, all right, we're gonna go old school, and I'm gonna do flat. So I guess it's not old school.
There we go.
Cool. All right. Thanks, everyone. Thanks for your patience. I'm Richard. I'm with Nature Conservancy. I'm the Urban Climate Resilience Manager. I'm thrilled to be here tonight, just with friends and colleagues on the panel. And I get the pleasure of talking about the results of the Philadelphia Urban Heat Mapping Campaign. So just give you an overview of what I'm going to be speaking about tonight. First, I'll give you a little bit of background on what are these heat mapping campaigns and what actually happened in Philly. We'll talk a little bit about the findings. Then I have a few of solutions that we'll dive deeper into and ways to get involved. All right, so these urban heat mapping campaigns, if you aren't aware, they're NOAA-sponsored initiatives where cities get funding and, well, resources to actually go out and map the urban heat island. And we all know that cities are generally hotter than their urban, suburban or rural surroundings, but these campaigns actually allow you to see how that heat is distributed within the city. And so Philadelphia was part of the summer 22 cohort. So Dana will be talking about her experience this past summer or last summer. But so we're part of different cohorts, but it's part of this broader initiative. It is a community science project. So the project involved dozens of community organizations and dozens upon dozens of residents, and always does so. These are the people who actually go out and do the measurements. And so you can see in this photo, that's Jackie. She drove a route in Southwest Philadelphia with her granddaughter and grandson, and all these campaigns equip residents with these monitors that they attach to their cars and go around and measure heat along the drive. So I'm not going to get too far into the background because I actually did another CC Run seminar in September of 2022. So you can check the video archives that talks about all the background for the campaign and what happened in Philadelphia. So this is also when I was over at the Academy of Natural Sciences. So huge shout out to them for being the ones who organized the initiative in Philadelphia. So I said there's a whole nother presentation on the background of these campaigns, but it is really important to talk about a little bit of why are these even necessary? Other heat maps exist. And so what makes these different? What's the unique value of these maps that you get from these kind of campaigns? Well, you're getting a snapshot of one hot day in a city. And so ours was July 30th, 2022 in Philly. And these sensors that people are going around with on their cars, they're measuring air temperature and humidity once every second. So when you look at other heat maps, which are incredible, they are very valuable and have a lot of applications, what you're usually seeing is the heat that's measured from surface temperatures. So those measurements are taken by satellites. They're usually passing over the city at one time of day, and they are measuring the roofs of buildings as much as they are any other type of land cover. So what you get with these NOAA-funded campaigns, or you get a sense of what's the air temperature and the heat index. And so we've talked to, Dan, and the questions reflected a lot of the importance of measuring humidity along with, air temperature. So this gives you a real feel, a picture of what's the real field temperature for people on the ground. The only way to really get this right now on a citywide scale and for one day like this is to have this massive mobilization of community scientists who go out and coordinate and use the same instrumentation and actually measure heat at the same times throughout the day. So that's a huge value. We also went out, and as do all the campaigns, at 3 different times of day. So like I said, satellites pass over our city maybe once a day, maybe it's in the morning. we're measuring temperatures with these campaigns in the morning, the afternoon, and the evening. So you can see how the temperature varies over time of day. And, you know, can't overemphasize the importance of the community participation. These campaigns produce not only data, but they produce an incredible amount of engagement on the topics of climate change, extreme urban heat, and quality of life. So I think, you know, that's just a point that cannot be overemphasized. So I do also want to shout out really quickly, in our case, in Philly, there were so many people that made the campaign happen. Kappa Strategies is Noah's partner, sort of technical partner that provides all the equipment. And Parks and Rec was a partner, PHS. We'll talk about their role a little bit later. The Nature Conservancy, you know, did a lot of the analysis that I'll be speaking about. But then there were over a dozen community organizations that participated as our community scientists and over 50 individuals. So without them, this could have never happened. Okay, so what's new? So there are a couple new products since summer 2022 that took a while to come online, but we're really excited to share them. It was a lot of data, over 38,000 measurements to process. So it's a lot of unwieldy heat data to get through, but we did it. And I should say all of the information is open source, meaning that you can go and get the individual measurements and a summary report for all of this at Open Science Framework. So it's open source, anyone can go there and get all these findings. And every city gets those products, they get the report. It's a static sort of report with maps in it and you know, all the data points. When I came over to the Nature Conservancy, we really were like, this is an opportunity, and we heard this from the participants when we shared those products with them, to make this information a little more user-friendly, a little more accessible. So what we have now is we created a story map, which if you're familiar, they're really fun, interactive, very graphic ways to sort of go through data. Ours is called Citywide Heat Ride, which one of our participants dubbed the campaign. And so you could go there. That really honors all the participants' experience and efforts for the campaign, and also gives a lot of information about the analysis that the Nature Conservancy did. And then you also have the sort of complementary web map where you can go and explore all the data layers, individual times of day, for heat index and air temperature. That's all accessible and searchable. You can see there's like a little search bar up there. So you can go there, you can explore these maps in much more detail now than you could before. So I'm going to talk a little bit now about the high-level findings, and then we're going to kind of do a deeper dive and tease out some of the nuances. So at a high level, our max temperature that day was 95 degrees. And so it was a hot day. July 30th, 2022 was a hot day. We got up to 95 that day. So it was a good day to go out. Some neighborhoods were as many as 10.5 degrees hotter than others. And so that's what we refer to as the temperature differential. So it was a 10.5, almost, 10.5 degree differential between one neighborhood to the other. And, as Dan was saying, these, in the long run, all of this shifting towards more extreme temperatures really, does make, it is important. So that could be really the difference on a really hot day between, having a health emergency or not in some neighborhoods. So that is a big differential. And I wanted to kind of put on there an example of that. So on the right, where the deep reds are, that is an area of, if folks are familiar with Philadelphia, that's Washington Ave, section of Washington Avenue. This is average temperature, but you can see that, we're really getting a lot of concentrated heat in that area. And then you see a picture of what the land cover is, and it's a lot of, road. I don't see a lot of trees. So you're getting, not a lot of relief there. On the other hand, you see an area of Mount Airy, and the Mount Airy section of Philly. This is Weaver's Way Co-op, which a lot of people are familiar with. That's in this area, and you can see sort of the cooling that's going on in there at the, on the same map. So in general, we're able to sort of see that if there are fewer trees in an area, they're hotter on average because that heat gets trapped by all those materials like concrete and brick and blacktop. If there are more trees, the areas tend to stay cooler throughout the day. And so these may not be totally surprising results, but we're going to get a little more into the details to sort of show why, it's not such a straightforward story. So to start that, I'm going to ask Nikki, I think she's going to help me out by opening up the chat. So I wanted to poll you all, what time of day do people think was the hottest temperature recorded? So we went out at 7 a.m., 3 p.m., and 7 p.m. So morning, afternoon, or evening. Morning, afternoon, or evening, when was the hottest temperature recorded? What do people think? And all right. We've got evening, we've got afternoon. We've got a very enthusiastic evening by Sean. Very confident, 5 p.m. Okay, I'll give everybody another second or two. Right, remember, we went out for an hour each time. It was, just to clarify, this doesn't really matter. It's still morning, afternoon, or evening, but we went out from 6 a.m. to 7 a.m., 3 p.m. to 4 p.m., and 7 p.m. to 8 p.m. Okay, so everyone's guessing kind of all over the board, which is great. So the hottest temperature was recorded in the afternoon. So pat yourself on the back if you guessed afternoon. We only know that because we measured 3 times a day. So we know what the variability there is. So it was that 95-degree high temperature for the day was in the afternoon. Okay, so next question. Oops, sorry. What time of day had the largest temperature differential? So remember, I said there was as much as a 10.5-degree differential between one neighborhood and the other. When do you think that the largest gap was? Was it in the morning, afternoon, or evening? And I'll let you put those answers in the chat. See if some of you can redeem yourselves. Okay, more. So yeah, not consensus by any stretch here, but I'll give you the answer. The maximum temperature differential was in the evening. So that 10.5-degree difference, and this is air temperature we're talking about right now, that was in the evening. And so Dan, said before, I think it was in response to a question, but nighttime is when typically you find the low temperatures. And that's a lot of times when the body has time to recover during a heat wave or, a really hot day. If we're seeing that max temperature differential in the evening, well, maybe there's some more investigation that needs to be had, because it's showing that maybe some neighborhoods are not cooling off as much in the evening as others, and that could be a point for intervention. So now we're sort of seeing the value of having these multiple times of day measurements. Okay, so speaking of time of day, okay, this is the last one. And I'm not going to poll you, I just want you to kind of think in your head. So since we're thinking of time of day, if you think of a map, like the map of heat for the morning, do you think that the heat is going to sort of stay in the same place, and those places that were hot in the morning are just going to get hotter in the afternoon and hotter in the evening? Or do you think that like heat is going to move around at all across the city? Is it going to stay put, or is it going to move? So I am putting up here, and this is from left to right. This is average air temperature, morning, afternoon, and evening. And you can see that heat is moving around. It is on the move, depending on time of day. So, for example, and it's harder to see this, and I encourage everyone to go on our web map, and you can really explore this much more easily. But for example, in what I noticed, and some other people I've shown these maps to have noticed, is that in the morning you're kind of starting off with this higher heat in kind of the core of the city, sort of almost the center city area, and then by the afternoon, that heat is moving around into different places, different neighborhoods across the city than it was in the morning. And then and then in the evening, you're kind of getting, and it's a little harder to see. Washington Ave, ironically, is very visible, but you can't really see it. But it's sort of moved back to where it kind of was in the morning, and it's more kind of concentrated in the downtown area. So, just knowing that is interesting and could inform some decision making. And there is some, I'm with the Nature Conservancy. I'm going to talk about a lot of green solutions here in a minute. But there is some, evidence that buildings cast some of the most effective shade during the day. And so it makes you think, maybe this downtown area has taller buildings, which is casting that shade, and that's why it's staying cooler in the afternoon. But then on the different times, it's sort of like absorbed that heat, and so it's radiating it back in the evening, or maybe it hasn't lost all that heat and it stayed hot overnight. So there's a lot of things to explore. While other areas are able to cool themselves, maybe because they have more greenery and less building stock. So it's kind of an advantage in the afternoon, but not so much in other times of day. So just sort of something interesting to think about. All right, so got to bring a little humor into a climate change and urban heat presentation. But as I mentioned, this is not just a campaign that measures air temperature, it's air temperature and humidity. So let's talk a little bit about heat index. So in general, what's a little bit interesting to note is that, so this is morning temperature and morning heat index. Like I said, it's sometimes referred to as the real feel. And you can kind of see just by a comparison that it's not a one-to-one sort of match. Obviously, humidity, it's showing the role that humidity plays at the same time of day, making some areas significantly hotter or different areas hotter. And so not only that comparison is interesting, but as you would see if you looked at the layers for afternoon and evening, whereas humidity is a little bit more prominent, heat index is a little more prominent in the morning, by the afternoon, the air temperatures are exceeding the highest heat index measurements, and in the evening also. So I've looked into this a little bit, and I think humidity tends to go down in cities throughout the course of the day. So again, as we're trying to figure out our responses to not only temperature, but humidity, heat index, that's good information that people could use to make decisions. The other thing is that I think a lot of people pick up immediately is this ribbon of dark coloring along our waterfront, particularly the Delaware River. And I think humidity has to be playing a role here, but it's not so much in the evening, but in the morning and the afternoon, those are very hot areas. And so what? Well, I think it does. It's another area that merits some more research. Franco had someone from Climate Central on in a previous CC Run webinar, and we were talking about why that is. And I don't think we have a really clear answer. I've heard anything from it's less shaded to the water is a dark color, so it's absorbing heat. There may be people on this call that could maybe speak to that in the Q&A or in the chat. But when we're talking about heat interventions, it's also something to think about is we're not necessarily only wanting to prepare places, neighborhoods for extreme heat. You also want to think about where are people playing, where is their recreation happening, where are people visiting the city? Are they in increased risk because they're on the waterfront and they don't realize it, and there's a lot of moist air, and that's a real health risk. I'm not an expert, but your body's natural cooling system is sweat, and when the air is too wet for you to really evaporate that sweat, your body can't cool down. You get in some serious health risks. So definitely something to tease out. Okay, so that's kind of all I've got for the findings. And now I'd like to pivot into solutions. And I'm going to talk about trees. If you're not a fan of trees, I don't know what to tell you. They're great. But just to make the case for it a little more and remind us all why trees are great, I'm going to show a very brief video. I hope it works. Okay, I'm sorry to pause it there, but could Nikki or somebody give me a thumbs up?
We could not hear, we can see it, but we can't hear it.
I felt like that was going to happen.
You might have to share sound when you share. You might have to not, try to share your screen again and share sound.
Okay. Hold on 1 second. I'm going to try to do that. Boom. Share sound. Yeah. Okay. I think this is going to work. Hear that?
Thumbs up.
Right. Thanks. I hope that was worth it. I love that video. And so we're going to show it twice. I like it so much. Let me see if I can advance. Okay. So, you guys see my slides?
Yep.
Really
we're back to your slides. Yep.
Okay. I just can't see you all. So trees. So at the beginning of when we were designing our campaign in Philly, we knew that we didn't want to necessarily just talk about how hot it was and just kind of leave people with no solutions. So we were very intentional in thinking about what's the action step that we can tie this whole campaign to. And one of the things we really were intentional about were trees. Now, why trees? Trees are nature's air conditioners. They not only provide that shade, but they also provide something called evapotranspiration, which is a fancy name for tree sweat. So when water evaporates out of the tree, it releases heat energy back into the air and doesn't keep it down here with us. So they have like dual cooling benefits, which are amazing. It's also important to note that it's not just about like one tree is going to provide all these cooling benefits, but it's really the tree canopy. So that means the layer of branches and leaves that can be seen from above from a bird's eye view. So the more canopy cover you have, the better cooling benefits. They are also one of the more cost-effective solutions. So if you don't like trees, but you want to solve extreme urban heat, look at the price tag for some of these gray solutions, and you might like trees more. So they're relatively inexpensive, especially compared to other gray solutions like, engineered, shade structures or something like that, in many cases. And not only that, they are an investment, they're an infrastructure that increases in value over time, as opposed to when like you drive a car off the lot and it immediately loses value. These are actually only going to increase in value. And then as that video showed, there are also enormous co-benefits for habitat for birds and butterflies and air quality benefits. And even in Philadelphia, we've pioneered a lot of research around how they can reduce crime and add to mental health, positive mental health benefits. So you wrap all of those benefits and the cost savings into one package, and I think they're a solution to really give a lot of consideration to. And we were not, we think it's important that trees go where, not just in the hottest places, but also where they're needed the most. And so luckily for us in Philly, this campaign was in, 2022, right around that same time, the Philly tree plan was getting developed. And I'm only listing Parks and Rec and Pennsylvania Horticultural Society on this slide because they were the partners that we partnered with the most on this, and they really did drive a lot of this, especially Parks and Rec, this tree plan. But there were so many that contributed to the tree plan, including Nature Conservancy, who was part of the steering committee. But what it gave us was, this was a plan that was already considering not just heat, definitely was considering heat, but they were also asking community and experts in the field, what are the other variables that we should consider along with heat to make, to decide where tree planting and care should be going on in the city. And so they were looking at heat, health, equity, environment. So with health, they were looking, for example, at asthma rates. With equity, they were looking at income. With environment, they were looking at air quality. So there was a lot of it was already sort of laid out there for us that we could kind of attach our data onto. So what they have come up with and had come up with at that time was this priority areas map, which you see on the far right. And in the darker, red and orange, those are the highest priority. All the colors are a priority area, but if they're darker, they're just a higher priority. But you can see they took into consideration not just heat. Now, when I say heat, remember, they were working with land surface satellite temperatures. So the heat that they were using is based on land surface temperatures. So we said, well, why don't we use the same variables, the same criteria that the Philly tree plan is using, but add our more high resolution heat data from the mapping campaign. And so that's exactly what we did. And we really worked closely with PHS, as I said, Horticultural Society and the Parks and Recreation. So I just want to shout out them again for being so open with their data and helping us to interpret everything. But what we got was the Philly tree plant, like the tree priority area 2.0, as I would call it. Now, that's not official. You know, it hasn't been officially adopted as the new priority areas for the tree plan. But what we did was we created our own map we called the area of need for trees. And then again, sort of using every same variable, all the weighting criteria, the same as the Philly tree plan, but just substituting the higher resolution heat data. And so what I'm going to do is just go. Sorry, can you see that tab? I can't see the participants anymore, so I'm just going to assume we're good.
Yeah, we can.
Okay, cool. So what you get now is, and this is from the story map. So if you want to go see this, you can go to Citywide Heat Ride. But you've got on the left, you've got the Nature Conservancy's analysis of area of need for trees. And on the right, you've got the Philly tree plan priority areas. And now what it allows you to do is say, you know, if you plugged in this higher resolution heat information, what would the comparison look like? And so a couple of points I'll just tease out without getting into like too much detail is that you'll probably notice in some cases one analysis has an area prioritized and the other doesn't. And so, for example, our analysis really had a lot more of the core of the city come up as a priority area, even if it was, you know, moderate. And what that's telling me a little bit is that even if you factor in health and equity and environment, the core of the city is winning, you know, so to speak, just based on heat. It's just so hot that it's going to come up as a priority, no matter what. So that's an interesting finding, I think. There are also some areas that are different priority levels on one map than another. So they're both priority areas, but they're just one's maybe moderate in one and high in the other. So, you know, that's just an interesting thing from the comparison. And what I'll say is that being purple, being a moderate need on this map, is a moderate need as compared to a highest need. It's still need. So if it's on this map, it is an area of need. So I don't want anyone to think that because it's purple, it's not a priority. It is. It's an area of need. It's a priority area. It's just letting, you know, it's just informing decision making. So, you know, that's all that really comes down to. And yeah, so this is data that now can be used by city officials, decision makers, communities, but overall, this is all really showing the transformational impact of the Philly tree plan. If it were implemented, you can just see, based on the heat maps, how this would be just so transformational in terms of equitably addressing heat and quality of life issues for Philly. So I'm starting to wrap up. My next slides, I really are about getting involved. And so I'm just going to use the story map to do that because we already have that section. And what I would encourage people to do is on the story map, instead of me going through all the different ways that people can get involved, is to just go there. It's a great resource. Again, we worked with our partners to kind of talk about as many of the opportunities to plant and care for trees in Philadelphia as we could. And so it talks about how you can get a free street tree, a free yard tree, how you can become a tree tender, how you can get involved with the Nature Conservancy, volunteer to be a natural land steward. And the other thing I would say that we really wanted to do is, and this is actually Franco's lab that helps to do this initiative, but there are also a lot of different resources that we call out that are not just trees, that help with energy burden, cooling homes, some gray, infrastructural solutions, not just the green infrastructural solutions, some emergency preparedness stuff, which is also just part of the suite of solutions that we need to take when it's getting hotter in our cities. So yeah, I think I'm going to stop sharing now and go to Q&A, but yeah, thanks so much.
Thanks so much, Richard. That was great. And it's really exciting to see how far the analysis has gone since your last presentation, and since that summer. So there's a bunch of questions. A bunch of them are around what was shown on the coast. And I'll just sort of throw in my own question first, taking the priority of the question asker. Is it possible that the GIS technique that was used to interpolate the data tried to meet a boundary that was assumed along the edges, and so it's an edge effect of the geospatial analysis? Just curious.
Interesting question. I honestly, I'll be really interested when Dana shows her findings, if there's anything along like a body of water, to see if she was seeing the same things. I do know that with the Climate Central maps that they recently put out in the past year or so, that was talking about urban heat islands, their waterfront, temperatures were high as well. So I don't really have the solution. I don't think that that's it. It's consistent with other maps that I've seen. I just don't know exactly why it's happened.
Interesting. Okay. So there were a couple of questions here about methodologies. So obviously traffic patterns vary significantly in the city. And I guess we have one question about what the extent to which you think that maybe some of the things that you show in the maps have to do with changes in traffic or differences in traffic, differences in vehicle exhaust, I'm guessing, things like that.
Sorry, changes in.
So differences in vehicular circulation, right? I mean, if you're in one neighborhood that has a lot of hot exhausts, it might be a function of if that neighborhood is coming out hotter, it could have something to do with the differences in vehicular usage as opposed to other factors. And the question was whether traffic patterns were similar in the different areas.
Yeah, what I can say is that it did occur on a Saturday, and to what extent that had a bearing on that variable, I'm not sure. I think that CAP Strategies has probably found a way to kind of control for that a little bit. These instruments are kind of about 6 feet above ground. They are in traffic in cases. So I know exhaust heat is something that contributes to the urban heat island, not just through vehicles, but like air conditioning, exhaust, things like that. I really don't know. I believe they probably controlled for it, and they match the measurements with, they do try to match the measurements with some satellite temperature readings from the day to sort of get rid of, they clean the data is what I should say. So if there's an anomaly, they usually look into it and kind of clean it. And our methodology is all up on our web map. So if people want to really dig deeper, I would say that's probably where you can do it. And it's probably a Kappa Strategies answer that is in their methodology. And I think Dana also, I would say, she may have some insights on that when she gives her talk.
Great. And then there's some questions about whether the neighborhoods that were adjacent to the coasts and whether the water areas that were beyond the coasts were compared to the coast? In other words, is this really a phenomenon that you're seeing right along the edge and it doesn't propagate on the water side or the land side? Your images, I guess it was kind of hard to tell because of the scale of the images, but
Yeah, I could even try to pull it up here in a second, but what I typically, it's like a ribbon. So it doesn't, from what I remember seeing, it doesn't really go very far inland. And so that's why when, someone was explaining sort of like, and you think about the Delaware River waterfront, you're not getting a lot of shade structures there of any kind, really. I think that may be why, is because once you move more, it's not far from when you move in that you start getting some type of shade, whether it's through a building or a tree or what have you. So I think it's really more localized to those ribbons of, what you're saying, coast.
but did your campaign actually send people out to the waterfront, like right at the waterfront, and collect data, or was that an interpolation?
So we drove up, like, for example, Delaware Ave. So we were right there on the water and in the river wards as well. So we're not on the water, but that's not really the scale that the data is meant to be interpreted at anyway. So it's a model. So it would have been fine, good enough to make that conclusion.
Yep.
But no, and that is again, a lot of this, I think, is just highlighting where there's more opportunity for investigation and research. So while we didn't go right there, this is the only way to get a snapshot of the entire city on one day, but you could put a stationary monitor out right on the water and kind of see these phenomena, and maybe weather underground or some other sort of more localized, hyperlocal weather station could get that information. I'm not sure.
Yep. And there's two questions here about perceptions. Lisa's saying that the end of Ray Street Pier always feels a lot cooler to the side that's sort of right at the edge of the land. And then Nate is asking, just observing that people like to go to the coast on hot days. Is that perhaps the wind? Is it that, it might be hotter, but the wind makes you perceive a cooler experience? Do you have any insights on either of those?
I mean, it is common logic, right? I mean, or sort of the proverbial wisdom. We all run to the coast on a hot day, so it is a little counterintuitive to me, and that's actually kind of an exciting part of the findings, is that we didn't want to just show what we already knew. We wanted to see some things that were a little counterintuitive. So I don't know. I mean, Dan's off the call, but his colleague Bradley Horton is, he pioneered some research around sort of like what's that dew point or that humidity level where the body can't cool off. And I have heard him speak to sort of like that wind is like a false sense of security. And if it's super humid, you actually are putting yourself in a dangerous situation without even knowing it. So I'm not the expert, but I do think that it may be sort of counterintuitive what's really going on there.
A few designy questions for you. If you want to say anything about which species of trees provide the best cooling, and if you have examples of trees that are like viewed by decision makers and infrastructure planners as infrastructure, like is there like a sort of workhorse tree that Philadelphia or other cities just always puts in to achieve cooling?
I'm partial to my fig tree in my backyard, but I don't think that would be the city's answer. And I'm going to just channel champions like Erica Smith-Fitchman, who works at Parks and Rec. I mean, I think the short answer is we want to be planting native trees above all else. I don't know if they're ones that give you more tree canopy cover than others, but the other thing is that trees have a bad rap in some of these neighborhoods, So I tend to think that as long as we're in the realm of a native tree, you want to get as much density as you can. And the tree is just the tree that the community supports. So whatever tree they want, I think is the right tree for that place, because you want to work with these community champions who are sort of having this uphill battle of getting people on board with trees again in some cases. So that would be my short answer. I'm not really sure though, but I love that it's piquing people's interest. And I would say, the Philly Tree Plan probably has a lot more information about all of that.
Yeah, and we're gonna have to transition quickly, but a couple more questions. I just want to try to get them in. In the tree priority map, were the various social, health, and environmental factors weighed equally in those maps? Do you happen to know?
I do know. And again, we took our weighting directly from the tree plan. So the only variable that was counted, so there was different weighting. Heat was counted twice. So it was weighted double all the rest. So that was also a reason it made sense to kind of look at updating that map, because they were already really prioritizing heat as the key variable there. So so that's why it's like tying heat and trees together, and what Philly is doing really made sense. But yeah, and then so heat was counted twice again, and in the methodology, I think everything else was counted equally, but you could go and see all of that in our web map methodology.
Yeah, and you're talking a lot about trees, but cool roofs are sort of also part of the solution. Do you have any sort of thoughts on trees versus cool roofs, where one is better than the other at achieving some of the goals we're talking about?
I'm not going to pretend I'm not biased. I'm, with the Nature Conservancy, but I mean, I think with the science, it's, I think you got to look at the whole suite of solutions. And while I don't know about cool roofs specifically versus trees, my sense from hearing a lot of other people speak about this is that the single, most important factor is shade. I think everything else works it complements that. It's again part of the whole package. But wherever you can get that shade, whether it be from a tree, a building, sort of an engineered sort of sail, or even an umbrella, like you all have done. I mean, I think that's the biggest single biggest solution that you can put in.
Great. All right, I think we're gonna have to leave it there just so we have enough time for Dana's presentation. But thanks so much, Richard. That was really informative, really exciting presentation.
Yeah, thanks so much.
So Dana, we'll switch over to you if you want to share your screen.
Sounds good. Hopefully this goes well. So let's give it a try.
And there's been there's a question that was up at the top that I didn't ask because I knew it was kind of your area of expertise, is a question about whether air is becoming more stagnant. And I'll just let you think about that and potentially address it later if you like.
All right, that sounds good. So I would like to thank very much the invitation to come and present here. It's very interesting to follow on to Richard's presentation, because the state of Delaware is about a year behind in this process. And I really feel that when I see the deeper analysis that you've been able to do for Philadelphia, I can see what's to come, or where similar ideas could really be beneficial for our area as well. My name is Dana Veron, and I'm here to talk to you about our heat mapping campaign and kind of the next steps that we have taken. But I feel like I'm representing a much larger group of people who've been involved in this project. For one, there's my co-director, Dr. Siders, with me in the Climate Hub. We've also worked very closely with Lee Aiken and Susan Love in the DENREC Division of Climate, Coastal and Energy. We also have worked very, very closely with colleagues at the Center for Environmental Monitoring and Analysis, which is housed at the University of Delaware, as well as with many partners who were both in existence before we started heat mapping campaign, or who have come into existence during this time period. So just to give you our timeline, we really got things going just back in June 2023, where we did our recruitment and laid out the mapping campaign. We did our heat mapping campaign in July of 2023, and then the data analysis was actually delivered at the tail end of the fall. And so we have just gone through a period where we've reached back out to Delawareans, both partners in the project, but also citizens who are interested, to talk about the findings of our heat mapping campaign and then start to meet with individual partners. And so we have started very large and then have kind of scaled down to individual meetings and even individual meetings with groups or neighborhoods. And now we're even scaling down further to meet with individuals who are interested. And then this summer, we have launched several new efforts with partners, which is what I'd like to share with you today. So just a map to orient yourself. You are looking at the northern tip of the state of Delaware. You can see it has kind of this funny arc shape to it, which is actually part of a circle that's drawn from a point in Old Newcastle. In this northern part of Delaware, our heat mapping campaign was confined to the orange area that you see. So you can see that it covers quite a lot of the city of Wilmington, and then we had surrounding townships such as Newcastle, parts of Newport, and so on and so forth. This white swath here is actually the Delaware River here. Our heat mapping campaign occurred on July 23rd. Our study area is pretty small. You might imagine that area is only 52.5 square miles. Because of the smaller area, we had 6 routes that were driven, and so we worked with about 3 volunteers per route, and that's 18 volunteers. Similar to the campaign that Richard described, we were out measuring 3 times for a total of nearly 38,000 measurements. Now, last year, if you recall, the beginning of the summer in particular was cool relative to the climatology. And so we actually really struggled to find a day that was really good for our heat mapping campaign that didn't also involve afternoon showers. And as you might imagine, it's been very, very warm here, but we also are experiencing many days where we're getting those afternoon thunderstorms, which makes it very, very difficult to actually do the heat mapping campaign. The maximum temperature that we measured was 90.7 degrees Fahrenheit, which is significantly cooler than the Philadelphia campaign. And the max temperature differential across our study area was 11 degrees Fahrenheit. If you look at the map that's in the center here, you can see the 6 routes that are actually planned out for that orange swath. You can see that they're very kind of variable routes that are designed by Kappa in collaboration with our community partners to really try and cover as much of variety in landscape use as possible. And so one of the reasons that they were interested in Wilmington is because we have a large amount of spatial variability in a small area. They also were still continuously interested in this proximity to a water body. So, this is the Delaware River here, but if you continue further south, it's really the beginning of the entry into the Delaware Bay. So we have a lot of available water surface with very, very high humidity. We were very lucky to partner with a newcomer on the scene at the time, the Delaware Resilience Hub. And so you can see Stacy Henry here and the crew that she helped recruit to work with us during the Heat Watch campaign. This was wonderful because the Resilience Hub, which actually functions as a cooling center during heat waves, also was our staging area. And so this was an area with a lot of parking, easy access, which really facilitated our process. So I did want to just show you here the one map that indicates that for the time period we were supposed to measure, which was in June, we had relatively normal to cool temperatures. And then this is just a zoom in on one of those routes to give you a clearer image of just how variable the land surface is. You can see that there are actually many tributaries that run into the Delaware River, such as the Christina River and the Brandywine Creek. And so there's a lot of kind of fine scale spatial variability in land surface use right around this central urban area. So I heard there were some questions about kind of what was happening behind the scenes once that data was taken. We sent the sensors off to Kappa, and then they took the data from the SD cards from those window mounted sensors. They do some very interesting quality control, so they have to trim the time window. So we were really stuck. Like if a data point was outside of the 6 a.m. to 7 a.m. window, it is not counted for that morning window. Similarly, they control to make sure that you stay in the route area, and they limit for car speed to try and decrease the impact of being stuck in traffic. And as I'll show you on some of our maps, you can actually see that data points were eliminated because some of our drivers got stuck in traffic. We also had data points eliminated because there was like last minute construction we didn't know about, and so we deviated from the route. Then what they do is they actually download satellite land use, land cover data, and then they combine that to go from the route data to extrapolate and build the map that you see here. They build those maps using a machine learning algorithm that combines both heat and land covered data to produce this map, and then they validate the data points. And so there's just a couple points that they drew out in the report that they provided to us that shows us, for example, here you see a very high density of roads, and it's also a very high temperature area in our combined heat map. So the underlying heat map here is an average of the 3 sample periods. So the maps produced for each time slice. And you can see that if you look at the land use map here, it's a very dense built up area. And so one of the things you see clearly in our maps is that indeed dense built up areas concentrate the heat throughout the day. Whereas you can see in this area here that's been pulled out in the report, it's pretty clear that this is a cool spot. And cool spots, if you go and look, very often are areas that, like Richard said, have that greater shade. So we have many parks in and around the city of Wilmington. Many of them are forested, and it's that shade cover that really allows things to cool down. I also wanted to point out, and we'll see this in some of the other maps, that there are some areas that are cool, but that are not forested. And those are areas where I think that we may be actually having some trouble with the interpolation algorithm. And so one of the things we're working on this summer is additional sampling. So if you want to look at the data that we collect, you can see here on the left-hand side, we are looking at the results from the evening traverse. So this is the example from the 7 to 8 p.m. time slice. You can see that the routes are shown here. So that's the actual data points as laid out on a ArcGIS map. Please notice that the routes are not continuous, right? We see actual breaks in the line, and that's just to remind you that that are periods that have been removed due to the quality control process for example, slowdowns in traffic and things like that. This data, when combined with the satellite data, actually leads to a map that looks like this on the right-hand side. And then I just wanted to show you that when you combine those two things together, in Esri, you can actually lay them on top of each other. And so I wanted to show the influence of the interpolation algorithm and the machine learning that is applied here, because you can see that there is a difference between the individual transect data points and the actual values for the interpolated area. And so I do think that we do see kind of this spatial averaging that happens when we do the interpolation. And so some of the extremes we saw in the individual data points may get a little bit averaged out in building the spatial map. If you look at our 3 time slices here, you'll see that the densely built up areas in the city are very visible in each one of these maps. I will point out, if you're paying attention, that I'm showing you images from CAPA as opposed to what Richard showed you, where he imported all of that data and then built their own kind of map around that. And so it looks like we have extreme temperatures in the morning. And that is when we do see our biggest temperature difference, but in fact, that's only almost 72 degrees Fahrenheit. So just notice that the scale changes from image to image. We do see very clearly that there are areas right around the densely built areas that are very, very hot. You see that throughout all 3 images. However, I would point out that we see this, and we have seen it in time series data as well, is that the city is not really releasing the heat in an equal fashion. And so you really see this heat retention that's happening in the densely urbanized area. We also see this this area along the river that may be related to what Franco and Richard were talking about. There are some areas that we see that are cool without the presence of parks. And so again, that's a place that we will be adding more sensors. So what are we doing with the maps? Well, there's lots of different efforts that are happening in the state of Delaware. You know, one of the things is we're really working on making sure that the people who live in Delaware, especially in urban areas, are informed about ways that they can keep cool. So we have a campaign that is really targeted at the community level to make sure that people understand ways they can keep cool or places that they can go. Property owners and landlords can think about ways to keep their houses cooler. And this is a state level effort in the sense that we are working on helping people to insulate their houses. And so you can have an energy audit done and then have some work actually done on your residence if you qualify to better insulate your property. I know the state is also thinking a lot about cool roofs, in particular white roofs is something that's been talked about quite a lot by the state. And then we can also think about community groups that are helping locate support services in the hottest areas. And so I feel like this is a place where Delaware has really grown this summer. We have 8 cooling centers that are currently operating in Newcastle County, which is our northernmost county. We also have 9 pools and spray parks. There are many people who are now getting involved in really trying to help better communicate and organize around extreme heat in the state of Delaware. So I'm showing you here a map that was created by Christy Arlotta, who is the sustainability coordinator for Newcastle County. She's also a former UD graduate and someone I had the pleasure of working with. You can see here in this map on the right-hand side, the location of the cooling centers, as well as the location of some public pools and spray parks. Please notice that we do have some cooling centers that are operating also in the city of Newark. So the city of Newark is not as large as Wilmington and was not part of the mapping campaign, but we do have some areas of kind of enhanced heat on our hottest days. And in particular, one of our cooling centers here on the outskirts of Newark is really focused on providing cooling relief for an aging population in a part of the town where there are no other possibilities for that community to go to. So there's not a senior center, there's not a library, or even some sort of like a town building readily available. And so this church opened up their space in order to serve that population. If you look at the map of where the cooling centers are relative to the heat map that we created, and so the best way to orient yourself is to look here at the bends in the Christina River, right? And you can see that they have been located here in this area of the map where we see some of the hottest temperatures. And so really trying to use the map as a way to orient resources that are rolling out at either the community, the city, or the state level. Some other things that are happening here in the state is work with schools and care facilities and businesses to think about preparing for the heat. In particular, I think there's been a lot of work thinking about how to be safe, especially as we're heading into the season for preparing for fall athletics for schools. There is a tree planting initiative in Delaware as well. I don't think that it is as coordinated around the heat map yet. We have not done an analysis like the one that Richard has offered. But there is the Tree for Every Delawarean initiative here where we're basically working to plant roughly a million trees throughout the state. And researchers are continuing to focus efforts on better understanding how heat affects family and thinking about both indoor and outdoor responses. And so I know that many of our community members were particularly worried about safe activities in parks. In many of our Wilmington neighborhoods, getting out, watching a ball game, things like that are really an important feature for the entire community. And many of their spaces really are not shaded, and so they become overheated. And so we're working with them to try and figure out what is the best type of shade that we might be able to work with them. I also know that some neighborhoods are actually working to pull out concrete and put in more porous and shaded features to try and cool down intersections where people are waiting for buses and things like that. And so really thinking about external and internal heat and how we can help our communities respond to that. One of the things that I've been particularly involved with in the last month or so is that we have been working on developing what we call a heat conditions report. This is work I'm doing with the Center for Environmental Monitoring and Analysis. The center, UD, is also the home for our state climatologists, so we have a lot of in-house meteorological expertise. And what we are doing is we have an intern who is combing through over 20 sources of information on extreme heat on a weekly or semi-weekly basis. And then he's combining and synthesizing that information to produce a report that uses language that's easy to understand. It's differentiated by county. There are only 3 in the state of Delaware, but they are different, and the amount of heat and humidity they experience does vary. We are utilizing the National Weather Service heat risk categories, and we are issuing this on Friday afternoons. And so that we're issuing this on Friday afternoons for 2 reasons. One of them is that we have heard from cooling center directors that they are having a hard time figuring out when to be open, and especially particularly when you think about planning for staffing, because it's not like our colleagues who are running cooling centers in Arizona, for example, where they just open, say, in mid to late May, and they stay open all the way through September because almost every day is above a 90-degree or 95-degree day. So instead, we are trying to help them think about how do they deploy their human and other resources to make sure that the cooling centers are open when we need them the most. And so although there are many, many resources that are out there by government organizations and other organizations, we have heard multiple times they're not quite sure which one to trust. And so what we are doing is trying to provide something that is easy to interpret that will help them make these staffing decisions. They're also issued on Friday afternoons because I know people are, especially the churches, do a lot of their planning right before Sunday, and then they make announcements on Sunday for when they're going to be open and when they need help from volunteers. It also turns out that the National Weather Service provides updates on Friday afternoon for a lot of their longer range forecasting tools, and so we wanted to make sure that we had the most up-to-date information. Now, for weeks that are supposed to be highly variable, meaning, we think that the forecast has the likelihood of changing significantly in the second half of the week, we also will be providing a midweek update. To give you an example of what this looks like, here's an example of the heat conditions report that we sent out last Friday. You can see that there's a headline that just says hot and very humid to start the week with more seasonable temperatures arriving later in the week. And then I pulled out some major phrasing in here, but there's a general summary. The first 4 days of the week will see heat indices well into the 90s, with some approaching and surpassing the triple-digit mark on Saturday. Remember, this was released last Friday, okay? There will be little relief from the heat at night. There's the potential for scattered thunderstorms across the state on Saturday and Sunday. And then moderate heat risk will continue through Tuesday before we transition to slightly cooler conditions on Wednesday. We're also providing a little bit of an outlook for the next week just to help with planning purposes. And then for each county, we are providing a day-by-day table that provides information on what the heat risk level is, the maximum heat index, and the minimum temperature. And we're doing that county by county. The color coding is matching the National Weather Service heat risk reference table, which I show here in the upper right-hand corner. And so you can see that the orange category here is moderate, and moderate is for levels of heat that affect most individuals sensitive to heat, especially those without effective heating, cooling, or adequate hydration. This is an experimental project. We're still working on this, but we have been working with community members to help us vet both the language and the display of the table, so a way that they can open it very easily in their email and understand relatively quickly what to expect in the coming week, where the highest variability will be, and how they might be able to deploy their personnel to be ready to respond to whatever the heat conditions will be in the coming week. And so I seem to have missed a slide in here. There are a couple of other projects I wanted to share with you, and I'm not quite sure why they're in my slides. So before I say my thanks, I'll just say that. One is that we are working on deploying sensors to provide us with more details about kind of the day-to-day variability in the extreme heat. Around the city of Wilmington, we already have 4 climatological stations from which we were able to get a longer, like decadal variation in heat already. But we're going to go back to some of those places on the map where we see kind of significant deviations that cannot be explained by how the land surface is being used. And so we're going to be housing several instruments there that will be collecting data throughout the end of the warm season. And then utilizing that data to help with a machine learning tool that will be doing neighborhood level, kind of block level prediction of extreme heat. We also have been working on a more dynamic map of the data that we got back from Kepa Industries. And so that will also help us better help people answer questions like the ones actually that Richard asked earlier in his presentation about how do we experience heat, and then how do people interpret the data that we're actually providing them from a more scientific resource, and how do they understand that relative to their lived experience. So I'd just like to say thank you to all the amazing volunteers and partners who made this project possible and who are continuing to organize and to respond to this summer's extreme heat. We are also working very closely with the state and many of our community partners. There is a real push to include extreme heat in the next state climate action plan. And so Lee Aiken in DENREC will be working with us and these other partners to really make sure that extreme heat and our state and local response to that will be included in that plan. And I think that's my last slide. Oh, my slides were actually out of order, but there you go. You got them all. All right, and I'm going to unshare my screen so I can respond to questions. Thanks, everybody.
Thanks so much, Dana. That was it was great. It was great to see these 2 presentations back to back too, and like what a tribute to the folks nationally who are making this stuff happen. That we're getting, you know, all of this granular information. I appreciated very much you sort of talking a little bit about the methodology that was used to process the data and the machine learning strategy. And there are a couple of questions about that, but I want to ask you one myself. So did I understand correctly that they selected the routes based on satellite imagery, and then part of the interpolation like looking at temperatures measured in specific land use categories and then inferring that that is the same for other land use categories within the map area?
Yeah, so the selection of the routes is a combined effort between what Kepa Strategies is looking for to make sure that they really get enough variation in land surface use types and community members. So like if I go back to the map, which map do I want to show you? This map. If you look at this map here on the right-hand side, you can see that there's a whole bunch of waypoints that are pulled out, like the Delaware Art Museum, the Brandywine Zoo, the various schools, the Children's Museum, things like that. And so actually we had community members who submitted waypoints, and they said, we would really like you to go by this thing. And so in particular, there were a lot of parks and things like that that were located in some of our BJ 40 neighborhoods where they're like, you absolutely have to go past this location because this is a place where the community gathers. Another example of this is like one of our most urbanized parts of the city of Wilmington is actually where the Social Security Administration's offices are. And so people go there, they take the bus there, they wait to get inside, they wait for the bus. And so that was one of the places they wanted to make sure that the route went by. So then Kepa takes all of these waypoints that have been suggested to them, and they look at them relative to the criteria they have to make sure that they have enough variation to do their mapping campaign. And then they send back to us routes. And then we had a moment to say, actually, this route won't work because it requires us to go on a highway and we'll go too fast. There's actually a speed limit that you can't go above as well. Otherwise, you're basically cooling, right? Due to the wind. And so we had some feedback, so we got to do a little bit of fine tuning on the routes before we did the final measurement campaign.
I get it. And then they take the measurements and the land use, and then they sort of spatially apply. So it's not like not to get technical, but it's not like a kriging. It's not like an interpolation between the data points. It's more of a like sampling and then applying the sample.
You would have to look at their documentation, which I did not refresh my memory of right before coming to this presentation, but I feel like there is both a kind of a kriging type, there is I think a distance or relaxation distance that's being utilized at the same time that there is a mapping across land use categories going on. I think both are happening.
Interesting. And so Lewis has a question here about validation, especially given the use of machine learning AI. And then what you do if you, number one, I guess, is there, what kind of validation is done? And then I guess secondly, like if there's data that's cleaned and thrown out, how do they interpolate the gaps?
So that I'll have to refer you all to the documentation for CAPA for that. I think that they are utilizing the fact that they have multiple data points across the same land surface types to kind of fill the gaps. So, a gap in a data transect is the same as a gap somewhere else in the map, right?
Right.
And the validation of the individual data points is done by CAPA strategies as well. They give it back to us, but as you could see in the one map that I showed, there are kind of point-to-point differences between the map and the transect, right?
Yeah.
And in some places, I, as a scientist, have some questions about what seems like significant differences in the temperatures, and those are places where I want to actually go back and do longer-term observations to see if we can better understand that variability.
Mm-hmm. And any thoughts on why at least from my perusal of what you showed, the coasts don't jump out as much as they were in Philadelphia? I mean, slightly, but not as much. Is there any thoughts on that? Is it different type of a coastline, perhaps, or?
That's a good question. We do have a part of our coastline that's very similar to the Philadelphia riverfront. It's really hardened, built up with like concrete walkways and parking lots and buildings and things like that right on the riverfront. But there's another part of I think there's probably a larger portion of the coastline that has a little bit of a buffer along it. And so there's kind of small strips of parkland or lawns or things like that. So it's not as hardened a riverfront.
Interesting. Okay. So that adds a little bit more sort of insight into what might be happening in Philadelphia with this sort of post-industrial landscape along the waterfront. That might actually include a lot of old concrete rubble and stuff that heats up. That's very interesting.
And we did not get far enough north towards, like if you get towards the Pennsylvania border, you get some of that in the city of Wilmington, well, just north of the city of Wilmington, but that was not really included in our area.
Yeah. So Lewis is asking a question about, in addition to email notices, do you have, or have you thought about sort of like a text tree or a sort of a chain of texting where you could get a hold of people? Any thoughts on sort of other ways of communicating?
The Delaware Emergency Management actually has a text notification service that goes out that citizens can sign up for. And I know that they have been working pretty hard to get the word out to get people to sign up for that. There are also announcements that are going out on a pretty regular basis. I think it's more frequent than monthly of like what cooling centers will be open and how you will know. And I know the Delaware Online has picked that up as well, and so they can update that. We are working, our aspirational goal is to get to the point that there's a Google Maps layer that you can turn on to be like, please show me the cooling centers. And then they'll pop open color-coded as to whether or not they're open on that day, but we're not there yet.
Mm-hmm. And the seniors, do you think you're catching them sort of like through the churches, or like, what are your thoughts on that?
So according to the pastors that we're working with, many seniors are really kind of flustered by the technology. Like they don't want to get notifications on their phones, right? And so they really do rely on communications coming from their trusted pastors on Sundays, letting them know what's going on. Or this idea of a phone tree has not gone away, but literally like people calling people to be like, today's a really hot day, don't forget. That kind of thing. The part of the reason that we are developing the heat conditions report is to try and help kind of regularize how non-technical leaders are talking about the heat. And so that we can, we've been very careful with the heat conditions report to try and use the same phrases over and over again to provide some sense of familiarity that will help then their parishioners or their community members, because they're opening their door to far more than their parishioners when they're open, so that they understand when we say it's this kind of heat alert, this is what's going on.
Yep. And then there's a point just about cooling centers, making this point that in New York City, often the cooling centers aren't open at night, when you might need, your body might need the most cooling. Are there, in your partnerships with the folks who run cooling centers, is there any discussion about when they're open? And is there any relief in evenings or nighttime?
So there is a lot of talk about this right now in our group. Right now we see a lot of our cooling centers are open until 5 or so. There's a couple of places where there's overnight accommodations for heat, but I think that that's something we're really going to have to expand on. So, right now I see that for kind of the current week, what we really have is cooling centers open until, say, 8 at the latest.
Interesting. Okay. Well, we're kind of, if there are no more questions, I wonder, just because I know your research includes coastal winds and sea breezes, there was this question earlier about whether with climate change, there's been changes in the motion of air. Like, are we stuck more in sort of hot areas of humid, latent, heavy air, or what's the relationship of climate change and wind? Is that well understood? I know it's a little bit beyond what you were presenting today, but just given your expertise, I wonder if you have thoughts on that.
All right, so I have lots of thoughts on that. The wind is changing and it's predicted to change. Part of the work that I do is on wind resource, so really looking at the winds that are available for generating electricity. And what you see from a global perspective is that the winds are changing. For example, in some places we are expecting to see an actual increase in the wind, where in other places in the globe they're actually seeing a small decrease in the wind and are expected to see that continue. I think one of the things that's happening right here that we experience very strongly in this part of the United States and in North America in general is that there has been a real change in the pressure gradient between the tropics and the polar regions. And that's due to the fact that the temperature gradient is not as steep. So, you used to have really, really high temperatures in the tropics and much lower temperatures in the poles. And now we're seeing that even out a little bit. And that is changing this wave train that runs around the northern hemisphere, which we recognize as part of it being the jet stream. Right. And so we talk a lot more now about how in the winter, there are these polar outbreaks that last a very long time, or right now in the summer, we experience this motion of warm, moist air masses coming from the Gulf of Mexico that stick around a really long time. And that's because we're seeing that that wiggle in the jet stream is getting larger, so higher amplitude, but the whole wave train is also moving slower. And so in the atmosphere, pressure differences at the surface really drive the winds. And if we see this change in high and low pressure going more slowly and changing exactly where those high and low pressure centers are, we are going to see changes in the wind. I also know from my sea breeze studies that we are seeing changes in coastal winds as well. We're not seeing a large change in like the kind of annual windiness, but if you look at it on a seasonal perspective, we're actually seeing changes in kind of the shoulder seasons, so spring and fall.
And these changes in sort of these large scale, like the jet stream, for example, down at the neighborhood level, can you detect, at that level, or are we talking about sort of like bulk movements of air that are in the sort of like upper atmosphere that you don't necessarily detect at the surface?
You will feel them in the surface winds, but I don't know that you would notice them like from this year to next year, right? Like it's more like if you've lived here for the last 30 years, you might notice that the periods of either very, very cold weather or very, very hot weather, they're hanging around a little bit longer, right? They're kind of taking longer to clear out. I do think it's influencing wind direction a little bit. And we do feel that at a highly local sense, especially in Philadelphia, not so much in Wilmington, but Philadelphia is known for its wind canyons because of the alignment of the streets. And so I think that if you live in the city of Philadelphia and the wind is coming out of a slightly different direction than it used to, and you've been around a decade or more, you might actually feel that as a lived experience.
Very interesting. Huh.
I think that surface roughness in the cities plays a much greater influence, though, than some of these very large scale atmospheric changes.
Yeah, and then that ties into the tree question, right? Because they're, I guess technically the trees would be increasing roughness, right? And therefore decreasing wind potentially. And is there like a potential sort of perverse impact there where it sort of I know I've heard that from an air quality perspective that like trees adjacent to buildings can actually hold contaminants down at the sidewalk level, but is the same true for, say, humidity?
Yeah, actually, there is some studies out there that show that we have to be a little bit careful in this mid-Atlantic region about how we plant our trees to make sure that there are breaks in the canopy to allow good recirculation to make sure that we're clearing out the air from both an air quality but also from a humidity perspective. And I think that's why your point to built structures that also provide shade but may also then still have venting or something to allow some wind circulation are things that need to be explored as well.
Great. Well, I guess with that, we're out of questions and we're pretty much out of time. So thank you, Dana, for all of that. And thanks, Richard, to you as well, and to Dan and to Nikki, of course, for organizing. I think this was a great session, really apropos given what we're experiencing. And thank you all. And we'll see you in September. We'll have a sequence of presentations September, October, November that we will be publicizing soon. Really exciting sequence focusing on sponge cities and universities and other things. So please keep joining us and enjoy the rest of your week.
Thanks, everyone.
Thanks.
Thank you very much.
Bye.